So did you move this to the other side or you moved these two? I'll do whatever you did. In here. Okay. So then I have x squared minus 11x over, how do you factor this?
X plus 3, x minus 2.
Minus x minus 3 over x minus 2, and you bring this over, so it's minus x plus 1 over x plus 3 equals 0. Agreed with this step? Okay, then I have how many restrictions?
2.
Good, and they are?
Negative 3 over 2.
And now I need, look, I drew a long fraction line, then the equal symbol and 0, because if I forget this, I mess it up. Okay, the LCD, please.
X plus 3
Times,
x.
very good. So now I need adjustments like we did before for 1.
X plus 2.
X
X minus 2.
plus 3. And
X minus 2.
very good. Do you all agree with this? Now we have to be very careful. 1 times x squared minus 11x is straightforward. But when I get here, it's just trouble. Negative x times x. Negative x squared. Negative x times 3. Negative 3x. Negative times negative 3 is positive 3 distributed to x. And positive 3 distributed to 3. Now, x times x with minus in front is negative x squared. X times negative 2 with minus in front is positive 2x. 1 times x with minus in front is negative x. And 1 times negative 2 with minus in front is positive 2. What do I have to do next? Yes. So, in a way, luckily these two go away.
Which should be x squared minus 12x minus
But
1.
negative. Negative x squared. Negative x squared. And then I have these two go away. Then negative 11x minus an x is negative 12x. Plus 2x is negative 10x. And then 9 plus 2 is 11. Agreed? Any questions so far before we continue? Okay. Now I'm in the proportion setup. I got rid of all the mess. So therefore, negative x squared minus 10x plus 11 equals 0. I refuse to solve a quadratic equation with a negative leading coefficient, ever. So then this is x squared plus 10x minus 11 equals 0, and now I know how to factor. How do I factor this?
X plus 11.
Excellent.
X minus 1.
So there are two options, negative 11 and 1. Are these on the list of restrictions? No. So they should be fine. Absolutely agreed. Okay, I would like to solve 46. I equals uppercase A over T plus uppercase B, and we're asked to solve for T. This is a model, and we're asked to solve for T. Okay, when you look at this equation, what will you say this equation is all about? What type? Okay, I'll give you a hint.
It's still proportional.
Right, so let's treat it as such. So tell me what to write.
A equals to T
IT plus,
plus IT.
good. I'm solving for t. What should I do next?
Divide by I.
Not yet. That will be the very last step. Division is at the very end. What do I have to do first?
You gotta get
Minus IB.
Right, I have to take this to the other side. A minus IB equals IT. I'm solving for t. Now I divide both sides by, of course, you can divide it term by term, or you can write it like this. It's up to you. Very good. I want to solve 50, which reads C. Any questions on this? C equals D, A plus, I think it's 1. Everything divided by 24. We're asked to solve for uppercase A. This is from medicine, and it's Howling's rule for child's dose. Medicine for a child. That's how they calculate it. That's the rule. Okay, what type of equation is this?
proportion.
Right. So then let's treat it as such. What would you write?
C over 1.
Right. So then 24C equals DA plus D. Have to distribute D. I don't have to, but that's one way. We're solving for uppercase A. What will be the next step, please?
You want to subtract values.
Very good. 24C minus D equals DA. And now I'm solving for A. So I have to divide both sides by D. Let's do it this time differently. So A equals 24C over D minus D over D, which is?
1.
Both are acceptable. This is acceptable. What is not acceptable is to cross out this I with this I. That is not acceptable because I is not a factor at the top. Good. Last section, I promise this is the last thing we have to do this semester, is complex rational expressions. By complex here, we should understand difficult. Well, you will tell me if you find those difficult. They're also called complex because they are stacked. Fractions with operations with fractions over fractions and operations with fractions. But we will be able to easily handle this. Okay, let's start with problem 19 on page 500. X plus 2 over x minus 2 over x minus 1. Everything over x plus 1 over x plus x plus 1 over x minus 1. Yep, I think I copied it correctly. So now you watch me or, work with me on this, and then you will see, and I'll ask you again if you consider them difficult or complex. Complex really doesn't really mean difficult here. It means
Tedious.
Thank you. Okay, so I see operations with fractions at the top. I'm not afraid of them at all because I see that the least common denominator is x times x minus 1. I know that the top one here needs x minus 1 and the top here needs x. I have to be very careful how I multiply these two. X times x is x squared minus x plus 2x and minus 2 and minus 2x. Nothing new because I know how to do this from 7.4. I will repeat the process for the denominator. So now the denominator has the least common denominator, which is x times x minus 1. This needs an x minus 1, and this one needs an x. But I know how to multiply x minus 1 by x plus 1. I know it's the difference of squares, x squared minus 1. And then plus x squared and plus x. So yes, I perform the operations at the top as if they're alone on this planet. I perform the operations at the bottom as if they're alone and not part of a complex rational expression. And now when I combine like terms at the top, I get x squared minus x minus 2 divided by x times x minus 1. And I know this will become a fraction. Have to flip it. So it's x times x minus 1. And the denominator will be 2x squared plus x minus 1. So I'm dividing a fraction, which is this, by this fraction, but I have to flip it because I have to change it into a product. That's how I know how to divide fractions, right? So a fraction over a fraction, right? Then I have to multiply it by the denominator flipped, right? Or the multiplicative inverse. So of course I have to state restrictions before I do that. I will simplify. And now I will try to simplify further because this is x minus 2 and x plus 1. And this one is 2x minus 1 and x plus 2. I'm wrong. That's 2x minus 1, minus 1. So 2x squared plus minus minus. Correct. So then I have one more restriction to write, actually two, after I flipped. Not 1/2 and not -1. And now I will simplify. I will write 1. And the simplified form is x minus 2 over 2x minus 1. Yes, there are many steps because I have to perform operations at the top. I have to perform operations at the bottom. To state restrictions, I have to flip the denominator. I have to remember how to multiply and simplify. And then add more restrictions because I'm dividing, and when I flip, a new denominator shows up. A new factor in the denominator shows up. And then, so all this, yes, 1 second, Cody, 1 second. So all this simplifies to this, assuming those conditions are fulfilled. Yes, please.
It's pretty much just dividing fractions.
Exactly.
Just
Right, but there are combinations. I have a division of two fractions, but first I have to add or subtract at the top, some fractions, add or subtract at the bottom, some fractions, and when I'm done and I get one fraction, then I divide them. That's why this is called complex, because you have many more operations put together. Okay, so would you like to redo this problem slowly? Okay, so let's redo this problem one more time. Let's do it one more time. So let's start slow. So the problem is x plus 2 over x minus 2 over x minus 1, and everything divided by x plus 1 over x plus x plus 1 over x minus 1. I think this must page 13 must be. Yes, 14. Can anyone give us the first step? This topic is the last new topic of this course.
Okay, so if there's anything to factor, you factor it first. But there's nothing to factor.
There is nothing, exactly,
So,
exactly.
That
will be even more,
but
hair pulling.
I
If I have even factor denominators, it would really take me 3 pages to finish it up.
will we have to use factoring for any of these for this unit?
That would be way too much. But no, I don't see anything here. No, I don't. So the book decided not to torture you that much. Maybe a little bit, but not. We're going to look at other problems in a minute. Okay, so the numerator has to have an LCD. The denominator has to have an LCD. So what is the LCD of the top?
X times x minus 1.
And you will state 2 restrictions, obviously.
Skip from 0.
Right. Very good. Good. So in that case, I know that the tops need something. The top of the first fraction needs,
X.
the top of the second fraction needs.
X.
Good. And now?
The numerator is
Yes.
Squared,
Yes?
negative x, and 2x. And then negative 2.
Excellent.
And then that's all minus 2x.
That's it. So see, in one step, I'm almost done with the top. Yes, I have to wait for a minute to finish the step for the denominator, but then I will just combine like terms, and it will be done. Okay, and now we look at the denominator as if it's alone on the planet. So in other words, what I'm saying, do not connect it with the top. You're just looking at the denominator, and you'll tell me what the least common denominator is. Okay, your book shows a totally different method. If you like it, use it. I personally think it's way more difficult than this one. Good. Then, this needs something, this needs something.
X minus 1 and x.
Good. So then,
That'll be x squared minus 1 and plus x plus 1 plus x squared plus x.
good. Any questions about the top or denominator? No. Okay. So now, I will combine like terms. Still write it one more time like this. It's okay. I skipped a step the first time we did it. So these two go away. So what is left at the top?
X squared minus x minus 2.
Now what is left in the denominator?
2x squared minus, or plus x minus 1.
Excellent. So right now we added or subtracted fractions at the top and we got a simplified form for the top. And we did the same thing to the denominator. We have a simplified form in the denominator. That's done. Now I'm asking myself, how do I divide these two fractions? And the answer is, I copy the first, which is the top one.
And then flip the other one and multiply.
Very good. Multiply by x minus 1 over 2x squared minus x minus 1. Oh, it's plus. I'm hoping that I can get rid of something. And right away I realize, already I stated restrictions, I realize that I can get rid of. Please write 1 so you don't forget that something is there or say something that it's not. Now I'm going to write x squared minus x minus 2 over 2x squared plus x minus 1. And I will give it a shot at factoring the top, factoring the denominator, in the hope that I can further simplify. And after I factor the denominator, I will add to this list the appropriate factors or restrictions. Okay, restrictions for the corresponding factors. So, the top.
X minus 2 plus 1.
Let's try the denominator. Very good. So the product is negative 2. And the sum is, 1. So the numbers are, since 1 is negative and 1 is positive,
Negative. No, 2 minus 1.
yes, negative 2 and positive 2 and negative 1, correct. So then I have 2x squared plus x minus 1 changes into
2x.
squared plus 2x
Oh.
Minus 1x.
minus x minus 1. Good. Then
2x.
2x.
X plus 1.
X plus 1.
Minus 1.
so I'm adding 2 more restrictions to this list. Can anyone give us the restrictions?
Negative 1.
Negative
Negative
1.
1 over 10. I mean,
Positive.
2.
Good. So finally, after 2 pages of writing, but I do have a big handwriting, I can get rid of
X plus 1.
and the simplified form is this. Assuming those conditions are fulfilled. Yes, it's a very long process. Look at this.
Click on make up a word problem.
Right. Good. Okay, let's do one more and then we'll stop.
What time is it?
6:03. 46. A to negative 1 plus 2a to negative 2 over 2a to negative 1 plus 2a to negative 1. So I know you're happy as to said we'll stop, but this will take 15 minutes. Okay, we'll make it.
The exponents.
As long as you promise not to drink and drive this holiday season.
You're gonna make me wanna drink it. Well,
You have to be awake to do this. Good.
Whatever the exponents we just wrote, right?
Right. So you can say, what does this have to do with what we're doing? But a to negative 1 means, thank you, plus 2 to power 1 times a to negative 2 means,
No.
2 over 2a.
2 over a squared. And now 2 times a to negative 1 is
1 over 2a.
2 has power 1. I cannot take it anywhere. 2 over a. 2 has power 1. If 2 has power 1, you're not allowed to move it anywhere. Only the quantity that has a negative exponent will go to the denominator.
So it has a parenthesis.
Ah, this is the next one. So then how do you write the next one?
1 over 2a.
That's a different story, correct. How many restrictions will you state?
A cannot be 0.
That's it. There is nothing else. There's nothing else. Good. Perfect. So then, the least common denominator for the top, please.
A times 2.
Careful, the least common denominator for the top. How many different
A
factors?
squared.
That's it. There's only one factor, and I have to choose its highest power. There's nothing else. It's a and a squared. So what does the top of the first fraction need? It needs an a. Please give me the top of the numerator.
2 plus a.
Yes, or a plus 2. Perfect. Let's look at the denominator. What is the LCD for the denominator?
2a.
Excellent. What does the first one need at the top?
2.
What does the second one need at the top?
1.
1. Very good. Or nothing. If you want to say nothing, that's fine too. What is the numerator of the denominator?
5.
Yes. Let's see. Let's show it like this for everyone. Perfect. Now I have the top, which is a plus 2 over a squared, and I have the bottom, which is 5 over 2a. I'm at the stage in which I have to divide two fractions. Simplified, fully simplified. What do I do?
A
Plus
the
2
first one.
over a squared multiplied by?
2a over 5.
Very good. There is an extra denominator now, but it's 5. I can write a restriction for 5. So I'm hoping to be able to get rid of something. Can I get rid of anything? an a from here,
Oh.
and 1a from here. Therefore, the simplified form, can anyone dictate the simplified form? 2 quantity,
A plus 2.
a plus 2 over
5A.
5a. Indeed, and the only restriction was this. So never be afraid of negative powers. They just bring the specific quantity to the denominator, not the whole thing. You just bring down only what has power -1
You said it was
or
okay
-2.
to
Yeah.
distribute.
You don't have to distribute. I prefer, because we always factor. I don't want to distribute. Very good.